April is here. Spring is here and the trees are budding and flowers are beginning to bloom, and we're in full swing for galaxy season. In this episode, we'll explore the planets and let you know how to see them, as well as exploring a unique crater on the moon. We'll talk briefly about the Great American Eclipse of 2024, which is on the 8th, and there's a comet that's approaching naked eye visibility under dark skies. That's an easy target in binoculars. We'll also discuss some of the best deep sky objects that are visible on April evenings. Just a reminder that we've posted both parts of our eclipse special, which is all about the upcoming total solar eclipse that'll cross the continental U.S. on a line from Texas to Maine on April 8th. The links to those episodes are in the show notes, and we'll discuss it a little bit in this episode as well. If you're watching on YouTube, please like the video and subscribe. This way you'll get a notification when a new video is released. If you're listening on audio, please leave us a nice review on your podcast platform. We really love getting your questions, suggestions, comments, and reviews. You can always email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. If you haven't joined already, please subscribe to the Astro Guy Podcast group on Facebook. We post lots of fun information there about astronomy and astronomers, as well as astronomy history. We want it to become a fun forum for all our listeners, so please check it out. The link is in the show notes. If you'd like to help support the Astro Guy Podcast and YouTube channel, you can always buy us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you. All right, I think I hear some flowers blooming. We better get to the April skies. Welcome to the Astro Guy Podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the Astro Guy Podcast. I'm your host, Wayne Zool. The big news for this month is the total solar eclipse that will make landfall in western Mexico. Then we'll follow a path from Texas through Maine and into Canada before heading out into the North Atlantic and then finally leaving the planet. This eclipse is being called the Great American Eclipse of 2024, and for good reason. There are more than 31 million people living inside the path of totality just in the U.S. alone. Estimates are that between 1 and 4 million people will be traveling to the path to witness the eclipse. In Texas, viewers can expect up to 4.5 minutes of totality, while those in Maine will experience about 3.5 minutes of totality. Total solar eclipses are amazing sights to witness, and to many people, they are life-changing. If you're in the continental U.S. but not in the path of totality, you'll still get to witness a partial solar eclipse. As we mentioned, we've posted 2 episodes about the eclipse. The links are in the show notes. In part 2, I talked about an app called Solar Eclipse Timer. I don't want to confuse anyone. This app is amazing. It is completely free to download, but in order to use it for Eclipse Day, there is a fee of $1.99 to get the data that you need for the April 8th eclipse. It's worth every penny. So if you want accurate timings for your exact locations, buy the data set. The Astro Guy Podcast does not get paid for this, but we don't want you to be surprised by the fee. Moving on, Mercury is visible early in the month of April, low in the west at sunset. On the 1st at 8 p.m., Mercury will be glowing at magnitude 1.6 while spanning about 9 arcseconds across, and in a telescope it will show a 14% illuminated crescent. However, it will only be about 7 degrees above the western horizon. Use brilliant Jupiter, located about 20 degrees east of Mercury, to help you find it. Binoculars will help, as will an excellent western horizon. Your best chance to see Mercury will be on April 1st, because by the 4th, it will likely be lost in the twilight glow and will be much lower on the horizon. Unfortunately, in April, Venus will be close to the Sun and will be nearly impossible to observe this month. Mars is now in the morning skies, rising at around 5:26 a.m. on the 1st, and at 4:25 a.m. on the 30th. Mars is shining at magnitude 1.1 all month and spans a little more than 4.5 arcseconds in diameter. You'll want a good eastern horizon to spot Mars. While appearing rather small, Mars will continue to get better as it makes its way toward opposition this coming January. Mars has an excellent conjunction with Saturn on April 10th, when the two planets will be separated by only 31 arc minutes, which is about the same angular size as the full moon. Saturn is slightly brighter than Mars at magnitude 1. At 5:45 a.m. on the morning of the 10th, the pair will be about 6 degrees above the east-southeast horizon. Again, you'll need a good horizon to spot it. Binoculars will help you to pick them out of the growing twilight glow. On April 1st, Jupiter is glowing brightly at magnitude -2 and spanning around 34 arcseconds in diameter. It will be easy to spot low in the western sky. At 8 p.m. on the 1st, Jupiter will be about 25 degrees above the horizon. However, by the middle of the month, you'll barely be able to spot Jupiter low in the evening twilight. And by the third week of April, it's going to be very difficult to spot at all. So get your Jupiter views in now, since it won't be visible until June, when it reemerges in the morning skies. On the evening of April 10th, the 7% waxing crescent moon will be 4 degrees from Jupiter, making for a stunning sight low in the western sky that evening. Saturn starts the month tough to spot in the morning skies, just before sunrise. On the 1st, Saturn rises at 5:43 a.m. That morning at 6:20 a.m., Saturn will be about 6 degrees above the eastern horizon. You'll need an excellent horizon and binoculars to spot it, but as the month goes on, it will become easier to pick out. On the 1st, the ring planet is glowing at magnitude 1, and with the rings it spans about 36 arcseconds across. The rings will appear closer to being on edge than when Saturn was last seen in the evening skies. On the morning of April 6th, if you have an excellent eastern horizon, you can spot the 27-day-old 8% waxing crescent moon, just 2 degrees below Saturn. Binoculars will help you to pick it out of the twilight glow. By the end of April, Saturn will rise at 3:57 in the morning, and will still be shining at magnitude 1, but if you have a good eastern horizon, you should be able to get some nice telescopic views of the ringed planet. Saturn is heading toward opposition in December, so it will get better as the year goes on. Uranus is visible as darkness falls on the 1st, about 3 degrees east of Jupiter. From a very dark sky, you can spot Uranus with the naked eye, feebly glowing at magnitude 5.86 and spanning a little more than 3.5 arcseconds across. Binoculars will help you spot it. As the month goes on, it will set earlier each night, and by mid-April it will be lost in the twilight glow until it reemerges in the morning skies in June. By the middle of April, you should be able to spot faint Neptune low on the eastern horizon as twilight begins. At magnitude 7.8, it's going to be tough to spot, but binoculars will help you find it. If you have a good eastern horizon on the morning of April 29th, Neptune will be a mere 10 arc minutes away from Mars. You'll need binoculars or a telescope to see Neptune, but it will look amazing, seeing two planets in the same field of view so close together. By the end of April, Neptune will rise at 4:25 a.m., and its disk will span just over 2 arcseconds across. As the year goes on, Neptune will rise earlier each day until it reaches opposition in September. Before exploring our lunar feature of the month, we have a celestial visitor that only graces our skies every 71 years. I'm referring to the periodic comet 12P Pons-Brooks. Comet Pons-Brooks was discovered independently by two astronomers, Jean-Louis Pons and William Robert Brooks. Pons first observed the comet on July 12, 1812, while Brooks rediscovered it on July 17, 1883. This is why the comet is referred to as P12 Pons-Brooks, to denote its periodicity, and Pons-Brooks, to honor both discoverers. There are even ancient records mentioning comets that might have been Comet Pons-Brooks. It is the 12th periodic comet that was discovered. The comet will reach perihelion when it will be closest to the Sun on April 21st. It will also be closest to Earth on June 2nd, when it will be about 1.55 AUs, or astronomical units away, which is around 232 million kilometers, or 144 million miles. As I record this, Pons Brooks is currently glowing at magnitude 5.5, with a tail that spans more than 5 degrees in length in long exposure images. In early April, the comet is predicted to become even brighter. It could reach magnitude 4.5, making it an easy naked eye target from dark skies, and an easy binocular or telescope object even from moderately light polluted locations. At 8 p.m. on April 1st, the comet will be about 2 degrees northeast of second magnitude Hamal in Aries. It will be about 20 degrees above the western horizon at that time. In binoculars, the comet's coma should appear as a diffuse glow that's brighter in the center. Because of the comet's activity as it nears the sun, its tail has been dynamic and changing. You'll need a good western horizon to see it. Start looking a little before 8 p.m. with binoculars. The comet sets a little before 10, so you should have a good hour plus of viewing it, depending on your horizon, of course. Comets are always unpredictable, but the comet should continue to brighten as April goes on. However, by about the 15th, it will be hard to pick it out of the twilight glow as it nears the sun, so try to spot it early in the month if you can. There's a possibility that the comet will be visible to observers within the path of totality during the total eclipse on April 8th. The comet will be about 5 degrees away from Jupiter on the 8th. You'll probably need binoculars to spot it, but spend your time enjoying totality rather than looking for a faint comet. At least that's my advice. Either way, try to spot this comet in April, as it won't be back in our skies for another 71 years. Our lunar feature of the month for April is the crater Clavius. It is one of the oldest and largest craters on the moon. Clavius is easy to locate in the southern highlands to the south of the crater Tycho, which we discussed in last month's episode. Named for the Jesuit priest Christopher Clavius, who was instrumental in the creation of the Gregorian calendar that we use today. His discovery of a nova in Cassiopeia, along with observations of others around the world noting the same exact position of the nova, helped determine that the stars were further away than the moon, and that the heavens can change. He was one of the most influential astronomers of his time. The crater is pretty impressive. It spans about 139 miles in diameter and is more than 2 miles deep. There are a total of 19 craters on the moon named Clavius. 18 of them are on the floor of the main crater. They are all named Clavius, followed by a letter of the alphabet. Clavius is best seen 1 to 2 days past first quarter. Keen-eyed observers can spot it with the naked eye, while it's an easy target in binoculars. Because of its position on the moon, it appears somewhat oblong to us, but lunar orbiters have imaged the crater from directly over it, and it is round. In a telescope, Clavius is an amazing sight. If you're using a scope with a long focal length, like a Schmidt-Cassegrain or a Maksutov, you should be able to crank the magnification if the seeing allows it. You'll be able to spot several of the smaller Clavius craters, which range in size from 27 miles across to about 2.5 miles across. On the rim of the main crater are 2 other craters. The larger one, spanning 33 miles, is crater Rutherford, named for Lewis Morris Rutherford, who took the first photographs of the moon through a telescope in the 1850s. Rutherford crater is located on the southern wall of Clavius. From Rutherford crater, you'll see a curving chain of several large craters. These, in order from Rutherford, are Clavius D, C, N, and J. On the northeast wall of Clavius lies the 32-mile-wide crater Porter, named for the father of amateur telescope making, Russell W. Porter. Porter worked as an architect for the 200-inch telescope at Mount Palomar, designing the buildings. His drawings are amazing. You can see many of Porter's original drawings at the National Archives in Washington, D.C., and online at Caltech or in Pasadena, California. He is also known as the founder of the Springfield Telescope Makers in Vermont, where the annual Stellafane Convention has been held each summer with just a few brief interruptions since 1926. Clavius even has its place in pop culture. In the movie 2001: A Space Odyssey, the lunar administrative facility was named Clavius Base. This is a fun crater to observe with any instrument. Please check it out and enjoy it. Now, moving out of the solar system, we're going to explore some of the best deep sky objects in Puppis the Poop Deck and Leo the Lion. We'll begin our tour in Puppis. Puppis is a large constellation that spans nearly 50 degrees of sky and is located just below the celestial equator, making it best seen in the southern hemisphere. But for us in the north, it is visible in our skies, albeit lower on the horizon. Our first object in Puppis is the bright open cluster M47. Glowing brightly at magnitude 4.4 and spanning 30 arc minutes, this cluster is a joy in any instrument. It's bright enough to be spotted with the naked eye from a dark site as a hazy patch about the size of the full moon. In binoculars, the cluster appears as a mottled glow, and you should be able to resolve about a dozen member stars. In a telescope, you'll resolve dozens of member stars within the cluster. M47 contains more than 500 stars, although many of them are faint red dwarfs that are very faint. M47 is located about 1,500 light-years away from us. Locating M47 is pretty easy. Start at second magnitude Mearsam and Canis Major, and sweep to magnitude minus 1.45 Sirius. Now follow that line for about 14 degrees, and you'll spot the cluster. Our next object holds a fun surprise. Let's take a look at the open cluster M46. This cluster was discovered by Charles Messier on February 19, 1771, from his observatory in Paris, France. Glowing at magnitude 6, the cluster spans about 22 arc minutes in size, and is comprised of about 500 stars. It is located about 5,000 light-years away from us. In binoculars, the cluster will appear as a hazy glow, while in a telescope, you'll be able to resolve dozens of member stars within this gorgeous cluster. With a 6-inch or larger scope, you should be able to enjoy the surprise object that appears on the northern edge of the cluster. There, you'll spot the magnitude 10.8 planetary nebula NGC 2438. Visually, the nebula appears like a small version of the ring nebula M57 in Lyra. NGC 2438 spans just over 1 arc minute in size. While it appears within the cluster, it is not associated with M46 at all. It is actually located much closer to us, only about 1,100 light-years away. To locate M46, sweep just over 1 degree east of M47, and you'll spot M46. Our next object is sometimes called the butterfly or the critter cluster. I'm referring to the open cluster M93, discovered by Charles Messier in 1781. The cluster glows at magnitude 6 and spans about 10 arc minutes in size. To me, the cluster appears sort of wedge-shaped. The late Walter Scott Houston described it this way. Some observers mention the cluster as having the shape of a starfish. With a fair-sized telescope, that is the appearance on a dull night. But a 4-inch refractor shows it as a typical star-studded galactic cluster. Those are Scotty's words, and that's the way that he described things. M93 is comprised of about 80 stars, and it is located about 3,830 light-years away from us. Finding M93 is pretty easy. Start back at Sirius. Located about 8 degrees southeast of Sirius sits a pair of stars, 1/3 and 1/4 magnitude. They are designated Omicron 1 and 2 Canis Majoris. To locate M93, imagine a line connecting these two stars, and then extend that line east-southeast for about 10 degrees, and you'll spot M93. Next on our list is the planetary nebula NGC 2440, which is sometimes called the albino butterfly nebula. This planetary nebula is slightly larger in size than NGC 2438, spanning 1¼ by 3/4 arc minutes in size, and glowing at magnitude 9.4. It is located about 4,000 light-years away from us. This planetary nebula is home to what is possibly the hottest known white dwarf star that has been measured to be about 400,000 degrees Fahrenheit. The nebula was first discovered by Sir William Herschel on March 4, 1790. Herschel described it thusly: a beautiful planetary nebula of a considerable degree of brightness, not very well defined. My notes of an observation of it with my 8-inch Dobsonian describe it as a small oblong glow that stands out well from the background. I've observed it through smaller instruments, but it's best seen in a 6-inch or larger scope, and if conditions permit, it will show details at higher magnifications. To locate NGC 2440, start back at M46 and sweep 3.5 degrees south, and you should spot the nebula. Let's now move a little bit east in the sky to the galaxy-rich constellation Leo, the Lion. Leo is easy to spot with its backwards question mark asterism and the bright star Regulus, shining at magnitude 1.3 at the bottom of the question mark. Regulus is a bright white star, and like many stars, it has a companion star. Regulus's companion is almost 7 magnitudes fainter, at magnitude 8.15. However, the secondary star is located about 3 arc minutes away from Regulus, so if you move Regulus just out of the field of view, you should be able to spot the secondary star. But we're not here for double stars, we're here to explore some galaxies. Let's begin with the Leo triplet, which as its name implies are 3 galaxies that all fit together nicely in a low power field of view. The brightest galaxy of the trio is M66, which glows at magnitude 8.9. M66 is a barred spiral galaxy that spans 10 by 5 arc minutes in size. It's located about 31 million light years away from us. You can spot M66 with large binoculars. In my 70mm refractor, the core appears bright, but the spiral arms are only seen using averted vision. In my 8-inch scope, the core of M66 appears pretty bright, with the 2 dimmer spiral arms visible just emanating from the core of the galaxy. Located just 20 arc minutes west of M66, and in the same low-power field of view, lies the spiral galaxy M65. This galaxy is slightly fainter than M66, as it glows at magnitude 9.3, and spans 8.5 by 2.5 arc minutes in size. It's a bit further away than its neighbor, lying 41 million light years from us. In my 8-inch Dob, M65 appears as an elongated glow that's a bit brighter in the center and fading as you move towards the edges. Located just half a degree north of M66 is the third member of the Leo triplet, NGC 3628, which is called the Hamburger Galaxy. It gets its name from its appearance in long exposure images, where it bears a slight resemblance to a hamburger peeking out from its bun. NGC 3628 is a nearly edge-on spiral galaxy that astronomers refer to as an active galaxy. It is listed at magnitude 9.48 and spans 14 by 3 arc minutes in size. It's located about 35 million light years away from us. In my 70mm refractor, the galaxy appears as a faintly glowing smudge, while in my 8-inch scope, it shows 2 distinct areas of light bisected by a dark lane. All 3 of these galaxies look great in a low-power wide-field view. They can even be glimpsed with large binoculars from dark skies. They're a lot of fun to observe. They're also very easy to locate. To find the trio, start at 3rd magnitude Chertan in Leo, and sweep 2 degrees south and 1 degrees east, and you'll spot this trio of galaxies. Our next stop is another trio of galaxies that easily fits into the same low-power field. If your field of view is at least 1.5 degrees wide, you'll be able to see all 3 at once, and if you're under dark enough skies with at least a 6-inch scope, you could see 5 galaxies in the same field of view. But for now, let's explore the 3 main galaxies that are part of this group. We'll begin at M95, which is the faintest of the 3 galaxies, glowing at magnitude 9.5, while spanning about 3 arc minutes in size, and lying at a distance of about 33 million light years away from us. M95 is a barred spiral galaxy that looks like a circular glow that's much brighter in the center, then fading quickly as you move outward from the core. Located just 40 arc minutes east of M95 lies M96, for which this trio is named. It's referred to as the M96 group. M96 is a face-on spiral galaxy that glows at magnitude 9.2 and spans 7.5 by 5 arc minutes in size. It is located about 31 million light years away from us. In my 8-inch scope, the galaxy appears more like an elliptical galaxy than a spiral, but long exposure images do show its true spiral structure. Located about 45 arc-minutes north of M96 lies the elliptical galaxy M105. This galaxy glows at magnitude 9.3 and spans about 5 by 5 arc-minutes in size. M105 is located about 32 million light-years away from us. If you study this field, especially at low power, you might notice another galaxy about 7 arc-minutes east of M105. This is the magnitude 10.2 elliptical galaxy NGC 3384, located about 35 million light-years away from us. This galaxy spans about 4 by 2 arc-minutes. My observing notes state that this galaxy appears very similar in appearance to M105, just appearing slightly dimmer than its neighbor. Appearing just 5 arc-minutes south of NGC 3384 is the galaxy NGC 3389. This one is a bit fainter, glowing feebly at magnitude 12.8 and spanning about 1 by 3 arc-minutes in size. It's also quite a bit further away, at a distance of about 80 million light-years. In my 8-inch Dob from very dark skies, the galaxy appears as a faint smudge of dim light, so it's a challenge for sure, but it can be glimpsed pretty easily in 8-inch and larger scopes from dark skies. To locate the M96 group, start at Churton and imagine a line to Regulus. Now sweep along that line toward Regulus for 7 degrees till you come to a 5th magnitude star. Now sweep south for just over 2 degrees, and you should be centered right on M96. I do hope that you'll go after these objects, and that they become favorites of yours as well. Well, that's all for this month. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com, or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.